Bismillahirrahmanirrahim. Assalamu alaikum students. This is Tariq. Today we will discuss about another descriptive statistical numerical measure median. In this section we will learn that how statistician can analyze, summarize, present and interpret the large data using descriptive statistical tool median, how statistician can identify the central data item of the data set using median, or how statistician can identify the mean or average value for the given data set to interpret the data using descriptive statistical tool median. In this section we will introduce another statistical tool median. We will define the median. So what is median? What is median? The middle position data item of the data set is called median of the data set. To identify the median for the given data set, first statistician has to arrange the entire data set in ascending or descending order. Ascending order means rewrite the given data set in increasing order. Start from smallest value to largest value. Descending order means rewrite the given data set in decreasing order. Start from large value to the small value. So first statistician has to arrange the entire data set in ascending or descending order to identify the median for the given data set. If the number of data items in the given data set are odd in numbers, means if data set include 3 data items, 5 data items, 7 data items, 9 data items, so these are all odd numbers. So if the data items are odd in numbers, then the middle position data item of the data set is called median of the data set. But if the data items in the data set are even in numbers, like data set include 2 data items, 4 data items, 6 data items, 8 data items, these are all even numbers, then the average value of the 2 middle position data item will define the median for the given data set. Means statistician will compute the average value of the 2 middle position data items, and that mean value will define the median for this given data set. So this is all about the median that statistician will use to interpret the large data. Let me read this theory. The data item at the middle position of the data set is called median of the data set. To identify the median of the data set, statistician has to arrange the entire data set in ascending or descending order. If the data items of the data set are odd in numbers, then the middle position data item is the median of the data set. But if the data items are even in numbers, then the average value of the 2 middle position data items of the data set will define the median for the given data set. So this is all about the concept of median. Now I am putting one note in here. We can determine the position of the median of the data set using the formula as given below. Using this formula, position of the median, statistician can identify the median for the given data set as well. Formula is this: position of the median is equal to n plus 1 whole divided by 2, where n is the size of the data set or the number of data items in the data set. Simply one can say capital N define the population or sample size. We will elaborate the concept of median by putting mathematical practical examples. For example, determine the median of the class sizes as given below. In this example, we are going to compute the average number of the average size of the class in the BBA department at Salam University. So this is example. This is the given data set which represent the class sizes, and we have 7 different classes. So the sample size is a 7. Capital N will represent 7. 15 number of students, 17 students, 12 students, 20 students, 25, 30 and 18 students. These are the 7 different classes. We will arrange the data set in ascending order. As I told you that to identify the median for the given data set, statistician has to arrange the entire data set in ascending or descending order. Suppose we will arrange the given data set in ascending order, like we will start from the smallest value to largest value. So 12 is the smallest value of the given data set, 12, 15, 17, 18, 20, 25 and 30. So in the very first step, we have to arrange the given data set. Now, if the sample size is odd in number, the data items in the data set are odd in numbers. As this is odd because in the example we have 7 data items. So the middle position data item is called median of the given data set. We have 7 data items, 1, 2, 3, 4, 5, 6, 7. This is odd number. So the middle position data item 18 is the median of this data set. And what is the interpretation of this 18? This 18 means every class of the BBA department carry approximately 18 students. Let me elaborate further, putting this note. Is data set size is 7, data items are odd in number, so the middle position data item, which is 18, is the median of the data set. I am again interpreting the practical importance of computing median. Is this that every class of the BBA department carry approximately 18 number of students. We will again elaborate the same example in a different way, so alternative way. Alternative mean another way, another approach. Identifying the position of the median of the given data set. So position of the median is equal to n plus 1 whole divided by 2, where n define the sample or population size. So sample size n is 7. We will put the value in this median position formula. Median MD represent position of the median of the data set. So location of the median of the data set. MD is equal to n plus 1 whole divided by 2, where MD represent median position in the given data set. So median data set size is 7, as this is very clear in here. We will put in this formula, substitute for this n, its value 7, 7 plus 1 8, and whole divided by 2, and 8 whole divided by 2. So 8 divided by 2 is equal to 4. What does this MD is equal to 4 means? So we locate the position of the data item in the position of the median of the data set. 4 means 4th position data item is the median of the data set, because this is we find out putting the value in the formulation, and we locate the position of the median of the data set. So 4th position data item is median, which is 18, not 19. This is a mistake in writing. This is 18, not 19. So median is 18, and as this is very clear from this data table, the first column define positions of the data item, second column define the data items. So 4th position data item, which is 18, I colored by green color. 18 is the median of the given data set. Interpretation is this, that the data item at the 4th position is the median of the data set, which is 18. So 18 is the median, as shown in the table by green color. So this is represented by green color. 18 is at the 4th position, and this is median of the data set. 50% of the data items are above the median, and 50% of the data items are below the median, 18. So it means that we can identify the median using 2 different approaches. One is this, that if the data set carry odd numbers, so statistician will identify the middle position data item, that is median of the data set, but statistician can use the formula position of the median. So from here also statistician can identify the location of the median in the given data set. Now we are changing examples. Suppose if the data set carry even numbers data items, mean 2, 4, 6, 8. So how statistician can identify the median for the given data set? For example, determine the median of the class sizes as given here: 12, 15, 17, 18, 20, 25, 30 and 32. The same example, but I just include another data item 32, that is the 8th data item. Now the data set carry 8 data items. 8 is even number, so it means statistician can identify the mean simply computing the average value of the two middle position data items. What are the two middle position data items? We can check from the table. The first column define the positions of the data items. Second column define the values of the data items. This is fourth position data item, which is 18, represented by red color. This is fifth position data item, which is 20. These two data items, fourth and fifth position data item, 18 and 20 respectively, these are in the middle of the data set. You can check first, second, third. 3 data items are above the fourth and fifth position data item, and 3 data items are below the fourth and fifth positions data items, 6, 7 and 8. So fourth and fifth position data items are in the middle of the data set. So data items are even in numbers. Statistician can identify the median by simply calculating the average of these two positions data items, means the average of the 18 and 20. So as this is given in here, let me read this note. As data set size is 8, data items are even in number, so the average value of the two middle position data items at fourth position, which is 18, and fifth position, which is 20. By computing the average of these two data items, statistician will identify the median for the given data set as this is given below. Simple mean. X bar is the symbol for the average value, for the arithmetic mean value of the two data items. 18 plus 20 whole divided by 2. This implies 38 whole divided by 2, and 38 divided by 2 mean value is equal to 19. Statistician define the average value of the two middle position data items, 18 and 20, at fourth and fifth positions. So that is 19, and this 19 is the median of the given data set. Interpretation is again this, that every class of the BBA department carry approximately 19 students. That is the practical importance of calculating this median value 19 for the given data set. Note, median is 19, the average value of the 18 and 20 data items of the data set. I am again repeating interpretation of 19. Why we calculate 19? This 19 represent the average number of students in every class of the BBA department. Now again we are using alternative way to identify the median for the given data set by using formula position of the median is equal to n plus 1 whole divided by 2, where n is the size of the data set, are data items, sample size. So we will put the sample size 8 in the formula we have. This is the formula, MD is equal to n plus 1 whole divided by 2, where MD represent median position of the data set. So MD is equal to 8 plus 1 whole divided by 2, and 9 whole divided by 2. 8 plus 1 is equal to 9, and 9 whole divided by 2 is equal to 4.5. So this 4.5 represent that median of the given data set, which is 19, is in between the fourth and fifth position data items. Means we have to calculate the mean value of the fourth and fifth position data items, which are 18 and 20. So 4.5th position data item is the median. It means the median of the data set is in between the fourth data item and fifth data item. So when we calculate the average value of the fourth data item 18 and fifth data item 20, we will find 19 as this is calculated in here. So 4.5th position data item is the median position. In here median is locating. Interpretation: median is in between the fourth and fifth position data items, and every class of the BBA department carry approximately 19 number of students. So this is all about how to identify the median for the given data set. Now we are switching toward another approach, how to find the median for the group data. In this section we will learn how to compute the median for the data set, which is in classes form, in group form, not as individual data items. Means that if the given data is not individually given, data items are not individually given, this is given, data is given in classes form, means frequency distribution table is given, groups form data is given, classes are given and frequencies are given. How statistician can define the median, the mean or average value for this type of data set? So we are learning how to compute the median for the group data. Methodology, procedure, how statistician can define the median. To compute the median for the group data, statistician will use few steps. Step number 1, identify the median class. In the very first step, statistician has to identify the median class, that particular class in which median will occur. So in which class median can happen? That first class of the data set is the median class which cumulative frequency exceeds or equal to the n over 2, where n is the total number of observation, total population or sample size, and we will divide it by 2. So that particular first class which cumulative frequency exceeds or equal to n divided by 2, that is called median class. That first class, I am again repeating, I am insisting, that first class of the entire data set of all the classes is the median class in which cumulative frequency exceeds or equal to n over 2. Second step, using the median formula, MD is equal to L plus R divided by F whole multiplied by C. Let me in the third step describe the median formulation. So third step, description of the median formula, where L represent lower limit of the median class, where F represent frequency of the median class, where C represent the class interval. What is class interval? Where class interval C is the difference of the lower limits of the two adjacent or consecutive classes. I am again repeating, class interval C. What is C? This is the difference of the lower limits of the two consecutive classes. Adjacent mean consecutive classes, as this is mentioned as a formula. Second step, class interval C, lower limit of the second class minus lower limit of the first class. We can compute the class interval using formula like this. We will calculate the difference between the any two consecutive classes. Statistician can define class interval using lower limit of the third class minus lower limit of the second class, or class interval C is equal to lower limit of the fourth class minus lower limit of the third class. So class interval statistician can identify by computing the difference between the lower limits of the two consecutive or adjacent classes, where R represent the required number of data items from the median class to reach to the cumulative frequency n over 2, and this is the formula to define R to compute the number of data items to reach the cumulative frequency n over 2 is given this formula. R is equal to n whole divided by 2 minus cumulative frequency of the previous class to the median class. I am again repeating, R is equal to n over 2 minus cumulative frequency of the previous class to the median class. Now we are clarifying further, putting one example. For example, compute the median for the given hourly wage rates of a company employees in the frequency distribution table. Means in the below given frequency distribution table, we have the wage rates, hourly wage rates for the 113 number of employees working in a particular company. So the total number of employees are 130. When we will add together all the frequencies of all the 5 classes, so this is 130, 60 plus 50, 110 plus 10, 120 plus 6, 126 plus 4, 130. So 130 is the sample or population size. And now is n divided by 2, this implies 130 divided by 2 is equal to 65. 130 represent the total number of workers in the company, divided by 2 is equal to 65. Now note, is second class is that first class which cumulative frequency 110 exceeds n over 2 is equal to 65. So second class is the median class. Come back to the frequency distribution table. First column define the number of classes, second column define the number of frequencies, third column represent cumulative frequencies. Now, as I told you in the previous slide, first step that particular class, first class is the median class which cumulative frequency exceeds or equal to n over 2. So this is very first step to identify the median class. When we are looking for the median class, so n divided by 2 is a 65, and second class, which lower limit is 6, upper limit is 10, is the median class represented by green color. M for median, C for class. Median class is second class. Why? Because this second class satisfy the condition that the cumulative frequency of the second class 110 exceeds the n over 2. N over 2 is a 65. And cumulative frequency of the second class is 110, which is the first class which cumulative frequency exceeds 65. The first class cumulative frequency is 60. This is less than n over 2. The second class is that first class. Second class is that first class which cumulative frequency 110 exceeds n over 2, which is 65. So it means second class is the median class, and median exists in the second class. Now if this is our median class, this second class, lower limit is 6. So in the formulation, L represent is equal to 6, lower limit of the median class is 6. Frequency of the median class is 50, so F is equal to 50, this defined frequency of the class. And C class interval is 5. How we can find out? Again, we can find out, subtract the lower limits of the two, the difference of the lower limits of the two consecutive classes. So the lower limit of the second class is a 6 minus lower limit of the first class is 1. So 6 minus 1 is equal to 5. So C is equal to 5. I am again repeating that class interval is the difference of the lower limits of the two consecutive classes. Like for example, the difference of the lower limits of the third and second class. So lower limit of the third class is 11, lower limit of the second class is a 6, 11 minus 6 again 5. So class interval is the difference of the lower limits of the two consecutive classes. Now we will identify R. As I told you, R represent the required number of data items that statistician required from the median class to reach to the cumulative frequency n over 2. So formula is this: R is equal to n over 2 minus cumulative frequency of the previous class to the median class. I am again repeating, R is equal to n over 2 minus cumulative frequency of the previous class to the median class. Now R is equal to N over 2 we calculate. This is 65. And now cumulative frequency of the previous class to the median class. So first class is the previous class to the median class. I am again repeating, first class is the previous class to the median class. Its cumulative frequency is 60. We will put in this formula to compute the required number of data items to reach to a cumulative frequency N over 2. So 65 minus 60, R is equal to 5. Put L is equal to 6, F is equal to 50, C is equal to 5 and R is equal to 5 in the median formula we have. MD is equal to L plus R divided by F whole multiplied by C. MD is equal to lower limit is a 6 plus required number of data items are 5 divided by the frequency of the median class 50 multiplied by the class interval 5. MD is equal to 6 as it is. When we multiply all these terms, so we find 0.5. And 6 plus 0.5, $6.5 is the median of the given group data. Interpretation. What does this $6.5 means? The hourly average wage rate of the employees working in this company is a $6.5. It means averagely every employee of the company is working per hour at $6.5. So this is all about to compute the median, the mean, the average value for the group data set.